Hey, hi, good evening, everyone. Yes, welcome back to our sessions on regression module. So, in the last session, we have understood the concept of linear regression, and in this particular session, we are going to come up with a project, a use case where we are going to implement the concepts that we have learned as part of earlier classes. Right. So, we'll quickly recap what we have covered. So, regression. So, when you talk specifically about regression, you know, the regression algorithms are used for continuous data. If you want to predict any continuous data, you are supposed to use regression algorithms. And the widely used regression algorithm is linear regression. What is the aim of linear regression is to come up with a straight line, linear line, to establish a linear relation between inputs and output. So that best fit line can be achieved through OLS technique, ordinary least squares technique. Then this simple linear regression, sorry, linear regression is again of two types: simple linear regression and multiple linear regression. Okay, so based on number of inputs, linear regression is divided into two types, right? If you have only one input, we say it as simple linear regression, and if you have more than one input, we say it as multiple linear regression. And this particular use case is also related to multiple linear regression. You see, all these are different features which talks about automobiles, which talks about automobiles. And some of the columns are relevant and some of the columns are irrelevant. Okay, so let us all consider the relevant columns, and the irrelevant columns we are going to remove. Fine. And what is the output column over here? You see price. The price is the output column that we are going to predict for the upcoming data. Okay. So let us use the concept of multiple linear regression. We'll come up with that equation y is equals to f of x. We'll evaluate the model and then predict the data. Right. So before I start the project, the use case, we'll talk about the data set. The data set consists of probably 26 features. Out of 26 features, we have 25 inputs and one output. 25 inputs and one output. So out of these 25 inputs, we should cross check the multicollinearity issue, whether we have multicollinearity issue or not. Then some of the inputs that are not required should be dropped off. Not each and every input is required, right? So the columns which are not relevant, the features that are not relevant should be dropped. Okay, right. So let us start our use case on predicting the car prices given with some input features. Okay, so what are we are going to start, we are going to implement the same crisp mlq procedure. Crisp mlq methodology is being used. I'm importing the required modules, the libraries which are imported. Okay, whatever are required, we are going to import them. The first one is pandas. Okay, so pandas is used for data manipulation. I'm importing pandas as PD. Then matplotlib.pyplot. Matplotlib is a visualization library, and we are not importing the complete matplotlib, only a sub package, sub library is being imported, and an alias name is provided. Then from sklearn, Model underscore selection, we are importing train underscore test underscore split. This is a method, a function which is used to split the data set into train and test. Okay, so I'm importing train test split as well. Done. Probably you can see here. Let me make it big. Yes. So friends, whatever we are using, we are supposed to memorize these, because as part of the project, these libraries are mandatory. Okay. Apart from these, yes, you can go and use any other libraries that are required additional, but these are mandatory. Okay. Then for building this linear regression model, I'm importing linear regression from sklearn dot linear model. From sklearn dot linear model, I'm importing linear regression. Done. Okay. Then from metrics subpackage in the same sklearn, I'm importing mean squared error and R square score. R2 square score is it returns us the R squared result. Okay. So mean squared error is an evaluation metric that we have discussed, right? Okay. As part of the evaluation metrics in the earlier classes, we have discussed mean squared error and R square score. Okay, R squared. So these two we are importing from the matrix sklearn, and simple imputer for imputation, one hot encoder and min max scalar. One hot encoder. What is the purpose of using one hot encoder, friends? What is the purpose of using one hot encoder? One hot encoder returns us, it is a technique used to convert categorical data into numeric data. Non-numeric will be converted to numeric using one hot. So earlier in the forenoon we have done a session, okay, in which we have came up with a naive based project in, okay, where I used label encoder. So what makes the difference between label encoder and one hot encoder? Yes, this is a simple question that we expect as part of our interviews. Differences between label encoder and one hot encoder. What is the difference? Okay, let me tell you. One hot encoder is generally applied on inputs. The one that you are seeing here is applied on inputs. But label encoder is implemented on, it is applied on output, the Y column. Okay. Then if you talk about differences, the output of one hot encoder will be either 0 or 1. So if you take any of the class, it will be converted to, the value will be converted to either 0 or 1. Only these two values you can expect as part of the output. But label encoder, no. Depending on the number of distinct values, the number keeps on changing. Then one hot encoder will result us in multiple columns. Okay, when you use one hot encoder on a categorical column where there are two distinct values, for example, male and female. So when you apply one hot encoder on one this particular column gender, so probably you'll get two columns, one for male and one for female. But if I apply same on the same column, if I apply label encoder, I get only one column, right? So all these points were being discussed and explained clearly as part of our previous session. So friends, if you fail to complete the playlist on 30 days free short-term training from Python to AI, do watch the videos, complete the playlist, so that you'll get a basic understanding about the EDA, Python, EDA, and data preprocessing. Okay, so all these steps are mandatory as part of any project that you do, right? Then I'm also importing min-max scalar. Okay, so what is the purpose of min-max scalar, friends? Why should we import min-max scalar? The question. Even in the forenoon session or on the project related to Navies, okay, we have used min-max scalar. What is the purpose of using min-max scalar? Min-max scalar is used, you know, for feature scaling. In order to scale the features, we use min-max scalar. So this point was covered as part of the same lectures. Okay, so I'm importing both the functions together. Yes. Now the question comes, Akil, why you are importing two functions here and only one function here? Okay, why can't you import all the three in a single line? No. If you observe clearly, simple imputer is imported from impute sub package, and one hot encoder and min-max scalar we are importing from pre-processing sub package. So a different sub package altogether. When the sub package is changed, how can you import all the three in the same line? Okay. So within a sub package, if you want to import one function or n number of functions, you can do it. Then outliers. In order to treat the outliers, we are going to use Winsorizer, the function Winsorizer, to treat the outliers. Let me import Winsorizer as well. Done. Okay. So when you try to import any of these particular functions, and if you get any error, if you face error, that means, you know, probably if you face any kind of no module named sklearn, no module named matplotlib, that means you don't have that particular library in your environment, in your local machine. So what you are supposed to do, you have to install it. How do you install it? We use either pip or conda as the tools to install these libraries. Right. Then profile report. So this is actually imported to from pandas profiling, an automated EDA package. Okay. So which is actually completing the entire EDA in a single go. I'm not expanding the EDA, journey, because EDA together takes lot of time. The main reason is EDA is a kind of analysis that we do on the raw data. On the raw data, we do analysis, right? So that analysis is called EDA, exploratory data analysis. And this analysis, what we do, when you do after when you complete this EDA, you'll get insights, and based on these insights, the management is going to take some kind of actions. When I talk about management, it is nothing but the client. It is nothing but the client. Okay. So as it is a big step, okay, as majority of the time gets consumed in the EDA and data pre-processing stages, you know, it is really a hectic job. I mean, it's a time consuming journey. So majority of the time gets killed as part of this phase. So in order to fast up, as we are running of time, I'm using an automated EDA package. If not, I can do the EDA manually also, friends. I can do EDA manually, but I'm not doing manually, I'm automating it. And finally, joblib is for saving the model. Okay, dumping the model, we are supposed to import joblib or pickle. Done. Done. Okay, so what I have done, I have completed all the libraries, whatever the libraries, required libraries that are important for us, I have imported. Now let us start our journey. What is the first step? The first step is to load the data set. The data set has to be loaded. Yes. How do you load the data set? What function is being used? Read underscore CSV. Why read underscore CSV? Because the data is present in a CSV file. But in real time, Akhil, for now it's okay because you know, as part of our learning journey, you're storing your data as part of a CSV file. This is fine, or an Excel file. Okay, so in order to read the data from a CSV file or Excel file, yes, we have functions which are available in pandas. Either read underscore CSV or read underscore Excel are available. But what about real time? In real time, is the data again stored in CSV file, Excel file? What do you think, friends? Is it the same? Companies like, Amazon, Google, do they store the data in their CSV file, Excel files? Where do they store the data? They store the data in databases, if not cloud platforms. Okay, so you might have heard about these cloud platforms, Azure, AWS, GCP, right? If not database, yes. Okay, so in either of these platforms, these companies, not only the top-notch companies, even if it is small company also, nowadays everyone started using databases. Okay, databases, and many of the companies, they started also storing the data in cloud. Okay, so that is the reason we the process will be same. Okay, so instead of getting the reading the data from an offline file, what we do is we connect SQL, I mean we connect database and Python. We integrate database and Python. Once after connecting both, you can fetch the data from the database. So friends, even this topic I have covered as part of SQL sessions. Okay, so only in this place I'll replace line number 16 with the connection of database. Once after making a successful connection with the database, what I can do? I can immediately start fetching the data. I can execute my SQL queries within Python. Okay, in Python script I can execute SQL queries. Is it possible? Yes, it is. I have already demonstrated a video on Python database connection. Okay, in case if you have missed it, yes, do watch. Right, so let us continue. Now I have the data present in an CSV file, and I'm reading the data using read underscore CSV function. And you see, once after reading the data, what is the size of the data set? It is 205 rows and 26 columns. Is it the same data set? Yes, it is the same one. ID, name of the vehicle, okay, the fuel types, then the length, the width of the car, okay, height of the car, weight, okay, horse ratio, bore ratio, stroke. So there are n number of columns that are related to cars. The all of them are related to cars. Okay, you see, and this is the Y column which we are supposed to predict the price of the car. Okay, only the price is in dollars. Don't assume it is in thousands. No one is going to sell. They are not ready to sell a car in thousands, right? Nowadays, it is actually in dollars, friends. Okay, whatever you see is represented in dollars, and we are supposed to predict the price of a car, automobile. Right. For that, what am I doing? I'm coming up with a model, and this model is going to get trained by the historical data. By using this data, it gets trained, and upon the new data, upon the you know future data, new data, it starts predicting the prices. It predicts the prices for the upcoming data. Okay, right. So what am I doing? I'm just printing data set sample. Okay, I'm just I want to print a sample of the data set. Then head function will return the top records. By default, it returns 5 records. Even though if you don't mention anything, the default number is 5. Okay. Then info function, it returns the basic information about the dataset, the non-null count, the column names. Okay. Seems like yes, there are null values in some columns. Okay, in car height, then curb weight. Okay. Uh, you see, drive wheels, door numbers, aspiration. So yes, what exactly happens is if you are a domain expert. So for example, if you are coming from a background from automobiles, say if you are from you know if you are graduated from mechanical engineering or automobile engineering, so you will be a domain expert as part of this project. Why? Because you are aware of all these terminologies. Am I right? Yes. So you'll be a domain expert as well. So don't assume that you know our knowledge, whatever we have learned with respect to our graduation, will be going there. No, somewhere it is going to use, because AI, this particular artificial intelligence, is getting incorporated in all the domains. Okay, so it's not only in manufacturing side. You take life sciences, healthcare. Okay, if you take banking sector, finance. Okay, whatnot, everything, civil. Okay, each and every domain, slowly and steadily, they're going to incorporate artificial intelligence. I hope it's making sense. So let us continue. Info function is going to give us the information. Okay, it is going to provide us the information of the data set. Then what does describe function does? Come on friends, what does describe function does? Describe function will return what? It is going to return the descriptive statistics. Okay, so the mean, median, mode. Explicitly it gives the count, mean, and standard deviation, q1, q2, q3, minimum, maximum, and median. Yes, for all the values you'll get. See, should we look after all these things? Yes, when you look after all these important aspects for each and every column, you'll understand the data distribution with respect to the column. The data distribution will be understood. Then what am I doing? I'm going to complete auto EDA by using profile report, pandas profiling. So let us store the output to a HTML file, see what happens. I have executed, and let's see. Is it done? No, it's still going on. You see here, it's in red mark. Okay, so it is talking about the action of kernel. It is still under the execution, so let us not disturb it. It's taking time. The reason is this is a data set with more number of columns, right? Compared to the data set that we have used earlier. So we have more number of columns in this data set. So that is the reason it is taking time. Because auto EDA should be done on, EDA should be done on all the columns. So it is taking time. That's okay. Yes. Is it done? No. Almost at the last, generating the report, framing the structure. Yes. So before that, let us discuss where will this HTML file will be saved, guys. This output HTML file just got completed. Now tell me, where does this HTML file will be saved? Where it gets saved? Don't tell in your local machine, okay? Because anyhow I know that it is going to store the output in my local machine. But in my local machine, where exactly it is going to store the output? This particular HTML file will be stored in current working directory. Good. What is my current working directory? How can I know what is my current working directory? Good. How can I know, you know, what is my current working directory? No. Okay. This was already communicated, right? Don't get confused. If you are using Spider, if you are using Spider, no, 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 no. So, friends, the majority of us we have a question: what is current working directory? Okay, the drive that we are using as part of running this particular program. Okay, so yes, we have to use get cwd, current working directory is the function. Good. But the advantage of using Spider is you need not use, yes, you need not use any function. Here itself you'll have the current working directory in Spider. So that means in E drive, okay, in these subfolders, in linear regression subfolder, somewhere I have the output HTML file. So let us navigate to that location. So is this the same path? E drive, NEUT, ML regression. So this is where I'll have my current working directory. See, and this is my HTML file. Let us open this HTML file. You see, number of variables, number of observations. Okay, so out of these 26 variables, 10 are non-numeric, 16 are numeric. Okay, are there any missing cells? Yes. Duplicate rows? Zero. No, none of them are duplicate. Okay, when you talk about each and every column, see, it is giving me the histogram to understand the data distribution, the names, type. So each and every column, with respect to each and every column, you have the data distribution visible clearly. Car body, drive wheels, wheelbase. So for each and every column, for all the 26 columns you have, if it is categorical column, you are getting horizontal plot, because lot of values you'll have for categorical. That is the reason. But for numeric values, it makes discrete bins and gives you a histogram: stroke, compression ratio, horsepower, peak RPM, city MPG. So all these, we have all of these. And finally, we have a sample of the data, the last and first 10 rows. Okay, so I need not explain all of these particular things, because earlier in the forenoon session also we have discussed the same pandas profiling concept. Whatever the insights that I got, I have just mentioned it here. No duplicates found, and features such as these features have missing values. Yes, there are some columns with some missing values. So let us address them. First of all, the irrelevant columns, the columns that are not required, what I'm supposed to do, I have to drop off. What is the use of having those columns? Why should I consider it? So if the columns that are irrelevant, let us drop them from the existing data set. Okay, so using drop function, I'm going to drop all these three. Okay, axis is equal to 1 represents columns. And why am I dropping price? Because I want to store the rest of the columns as inputs. So when you remove 3 from 26, it becomes 23. 23 will be as part of my inputs. 23 columns will be part of our inputs. And price column, I want to make it as output. So Y will be a series. So this is price, and these are your rest of the columns. Clear? Now, what am I doing? I am going to again separate numeric and non-numeric from X. From inputs, I want to separate numeric and non-numeric. For that, I am using select d types function. So inside select d types function, what am I doing? I am including object category. So this is going to have only categorical columns. So how many categorical columns we have? Let us see. Categorical, 9. 9 categorical columns. And how many of them are numeric out of 23? So obviously 23 minus 9, 14 should be the output. Good. Okay. So Akhil, what is the reason for separating numeric and non-numeric, categorical and numeric columns? Because when you are trying to do data pre-processing, when you are starting your data pre-processing steps, for categorical columns you have to do in a different way. For numeric columns you have to do different way. Why? Isn't it? Yes. See, if there is a missing value in categorical column, can I use mean as the strategy? No, because for numeric columns, yes, obviously I can calculate mean. But for non-numeric column, how can I calculate mean? Impossible, right? So that is the reason we separate both categorical and numeric columns. Once after separating them, what am I doing? I'm creating them. Once after separating, I'm creating data frames: x categorical, x numerical. See, clear? From x we got two data frames in which we have numeric and categorical columns separated. Done. Now let us get the sum of null values. Let us calculate the missing values sum. So in categorical columns, if you see, only in three columns we have missing values: aspiration, door numbers, and drive wheels. For that, what am I doing? I am coming up with a strategy that is mode. Most frequent is being used to impute the missing values. So I'll use simple imputer. Within simple imputer, I'm going to use most underscore frequent as the value for strategy, which represents mode. So the most repeated value as part of these three columns will be imputed in place of null values. So simple imputer initialized. I have initialized this function and stored it in imputer, and this imputer becomes my function now. And what am I doing? I'm using this imputer function and I'm applying I'm going to fit on the X categorical columns and transform the results. Okay. So when you transform, the column name should be taken from X underscore categorical only. And finally, you know, I want to convert the output to data frame. See, done. Once after completing, the imputation part on non-numeric columns, categorical columns, let us go and check. After imputation, do we find any null values or not? The same logic. Is null checks whether it is null or not. Each value, each cell of that particular data frame, it checks whether it is null or not. If it is null, it adds up. If it is not null, it doesn't add. It returns true or false. Okay. So that is the reason there is no null value after imputation. Done. Now let us apply one hot encoding on the non-numerical columns. Let us convert it into numeric. I'm applying one hot encoder initialized, and then I'm applying it on the non-numeric columns. Okay, so they got encoded, and finally what am I doing? I'm converting back the output to data frame. So let me show you the output. X categorical encoded df. See, now all the non-numeric columns got converted to numeric columns using one hot encoding. If you see, even the column names that if you observe will be represented with the class names. If you have gender as the column, I'll just give an example. If you have gender as the column, and the gender either you'll have male or female. So when you apply one hot and one encoder, you get two columns: gender underscore female, gender underscore male. Am I right? Yes. So gender underscore female, you'll have some column values, and gender underscore male also you'll have the values. So that is what it has done. Right. Then we are done with categorical columns. All of them, all the pre-processing steps on the categorical columns have been done. Now let us start working on numerical columns in inputs. Okay. So let us first start with encoding. I mean, missing values. So if you see 1, 2, 3, again under numerical columns, we have three columns in which there are null values. So what I'm doing is initially I'll visualize a box plot. Let us check if there are any outliers or not. If there are outliers, yes, it's better if you change the strategy. That would make sense. Yes, there are outliers. You see, there are outliers in the columns. So what should we do? You suppose if you have outliers, you better change the strategy. If you see here, if you have outliers in the column, you know use median as the strategy, because median strategy does not get influenced because of outliers. Okay, just because of outliers, you know it does not get influenced. So for that, I'm going with median strategy, and I'm using only on one column, it is car length. So in car length probably there is no outlier. That is the reason I'm sorry, I have outliers. Okay, I have outliers in car length column, so that is the reason I'm going and using median strategy. Okay, so the median strategy is not influenced, right? So it got imputed. In some columns we don't have outliers. Okay, numeric columns, and in those columns you can go and use mean as the strategy. Okay, so again I'm initializing simple imputer, and in car height and curve weight, there is no outlier. Yes, the mean strategy works, because mean is getting influenced by outliers. It's better if it is always recommended to use mean strategies on the columns where they don't have outliers. And finally, What you are doing, you are going to calculate the null values after imputation. After imputation, do you have any null values in the numeric columns? No, there is no null value present in the numeric columns post imputation. Done. So let us work on the outliers that we have. Let us treat the outliers. For that, I'm using winsorization. I'm using IKEA method. Okay. So winsorization was being initialized. And what am I doing? I'm taking this winsor, the initialized winsorization. Okay. So this winsor is getting fit and transform the X numerical columns. Whatever is part of X numerical, they will be transformed. Done. So if you go and visualize box plot on X underscore numerical underscore winsorized, it should not have any outliers. So let us see either it worked or not. Did it work? Yes, it worked. I don't see outliers in any of the column. In any of the column, there is no outlier. Okay, so that is the reason it worked. Probably what, Akil, if it does not work, you change the strategy. You change the method. Here we tried IKEA. Why don't you go and use Gaussian? Why don't you try MAD? Why don't you use percentile? Okay, there are different methods that you can come up with. Okay, so the insight is there are no outliers. They got handled effectively. Good. Now, the final step as part of data pre-processing is we are going to scale the features to be scaled, right? So what am I doing? I'm initializing min-max scalar. Initialized, yes. This min-max scalar, I'm going to fit and transform on the output of box plot. I mean, the winsorization. Okay. So the final results should be converted to data frame back. So X underscore numerical underscore scaled will have the scaled output. See, all the values in all the columns will be between 0 and 1 only. The minimum value will be 0 and the maximum value will be 1. Okay. Yes. So this marks, okay. Anyhow, what am I doing at the last? I'm going to concatenate both numeric and non-numeric columns, the categorical columns, based on axis is equal to 1 represents columns. So I'm combining both of them and I'll store it in X underscore final. So this is my final inputs after data pre-processing. Now taking these inputs, what am I doing? I'm applying train test split. I'm applying train test split. So this is going to split both inputs and output into four parts. What are the four parts? X train, Y train, X test, Y test. Train data, test data. Okay. In both train data and test data, you'll have inputs and output. Okay. So what is the size of my test data? 20%. What is my output of, what is the proportion of data that I'll have in train? 80%. If test hold 20, obviously train should hold 80. I hope it's making sense. Yes. Now, let us build the model. Last stage of no this particular project is building the model. So I'm using linear regression. Okay, I'm initializing the function and I'm storing it in model, a variable. This model is used on it is going to be fit on train data set. X train and Y train will pass both and the model gets trained. Okay, that Y is equals to f of x equation gets built in the backend. Oh, sorry, this is not executed. My bad. Yes, it's done. Yep. The model got trained now. Once if the model got trained, what is the next step? Once if the model got trained, obviously the next step is predictions. So I'll use the model, I'll predict it on train data. So when you are going to predict, you should pass only inputs. Output should not be passed. There is no point of passing output. When you pass input, it should return output. Okay, your prediction should be written. So that predictions I'm storing where? I'm storing in y underscore pred underscore train. The same thing I'll do it on test data also. Yes. On train data I got predictions. On test data also I got predictions. Then these predictions, are they good or are they bad? We have to evaluate. We have to evaluate. What are the metrics that we consider here as part of this project? One is mean squared error, and the second one is R square, the score that we get as part of R square. Right. So if you see, what is the mean squared error that we are going to get for train data? Let us see. Okay, I'm storing it in MSC underscore train that I'll print later on. Then I'll repeat the same process for R square score. I'll get the R squared score when you pass both predictions and the actuals. Okay. In the same way, I'll do it for test data set. Done. Now let us print all the results that we have got. Whatever we have got, let us print all of them. The model evaluation. So as part of model evaluation, the first one that we are going to see is the training mean squared error. What is the training mean squared error? See how big it is. 36,000. Oh, it's not even 1,000. It's a very big number. Okay, so that is the reason you will not generally consider mean squared error. It's better if you take MAPE into the picture. It is always recommended to take MAPE so that it is easily interpretable. One can understand MAPE value very easy because it is representing percentage, right? Yes. Let us talk about R squared. It is 0.94. Oh my god. It's a very good model that we have come up with because R squared score lies between 0 to 1. Higher the R square, better the model, best the model. So 0.94, it is close to 1 or 0. Obviously, it is close to 1. Okay, so the model that we have come up is, it's a very good model, and I'll do the same for test data also. I'll replicate the same. So MAPE MSC is returning us very high value. Let us not include it. And even on test data, it is good, 0.79. Okay, so somehow it is good. When we tune the model, still you can get better results. Okay, but I did not include any tuning process. Okay, so the insights that we see observe here are high R squared score on training data, but comparatively we observe low R squared score on test data. But that is not, this is not, you cannot say this is very small. This is also good, acceptable. Okay, so this is acceptable probably in manufacturing domain, but if you go and use, or if you go and do the same project in some other domain, probably this R square score is not accepted. That is why I'm talking the evaluation metrics that you are going to consider. Okay, even though if they are very less in some domains, if they are not that much critical domain, they are accepted. But if you take a domain like life sciences, healthcare, pharma, okay, where it is a critical domain which is related to life of a person, so in that case the accuracy, the error should be very less, accuracy should be very more. Okay, so that is how it varies. Don't assume that even though if I get 80% accuracy, it is not accepted. It is accepted, might be in other domains. Okay, so that's how the interpretability changes with respect to the domain. Okay, as part of machine learning or AI, okay, the applications that you're going to build completely depends on the domain. Okay, it completely depends on the domain. So initially you're supposed to understand the domain also as part of your project. If you are not from the same domain, anyhow you'll have subject matter experts, the domain experts, taking the help of subject matter expert or a domain expert. Anyhow, we can now build our model. Okay, and finally what am I doing? I'm going to save my model using joblib. So why should I be save the model? Once if you got the best model, you have to save it. If you don't save, how you're going to predict on the new data? For example, I'm going to manufacture a new car. Okay, when I manufacture a new automobile, a car, I'll have all these inputs. All the inputs will be there, but what will be missing? The missing one will be price. So using my model, I can predict this price when I pass the inputs. So for that reason, you have to save your model. The model that you have built, if you feel that it is, the best model, then you are supposed to save it. Okay. So yes, how you are going to save it? Using joblib. There is a library called joblib. If not, there is one more library called pickle. So using these libraries, we dump the model, we save the model, okay, with a name. So you're supposed to give a name as well. So this is my name of the model, and this particular model gets saved in your, again, current working directory. So would you like to do, shall I do it? Yes, anyhow I'll do it. I execute it, then I'll also print the statement. Model saved as mlr underscore model dot pkl. So the model got saved. Where will we have? We'll have that particular pickle file, in our current working directory. So majority of us will have a question: what exactly is present in this pickle file? Pkl stands for pickle. Okay, so this pickle file, let us open via notepad. Let's see. You able to understand anything? No, right? So it is generally, written in the format of binary, and uh, some kind of security concerns are also being assigned to the file. Okay, so when you try to predict on the new data, what you'll do? You'll use the same file for predicting on the new data. On the new data, I'll use it and predict for the upcoming cars. If I want to decide, if I want to predict what is the price of the new car, okay, I can use my model, and this model will give the price of the automobile, the car. Right. So we have successfully done a use case on linear regression as well. I'll stop it here, and it's time for our questions. So friends, tomorrow we are going to start a new type under the regression. It will be logistic regression. So again, the same process will be followed, starting again we'll use, there is a function called load from the same library joblib. So you load the model, and you can use it on the data, on the future data. For example, don't pass price column. Okay, if you take even the same data, don't pass the price column and use it. It is going to predict. So obviously I'll show it on the next algorithm. How you can use the model, I'll show it in the next algorithm. The process will be same. So from algorithm to algorithm, only you're changing the algorithm. Okay, so if you understand the process as part of supervised learning algorithms, whatever the process that we follow will be constant. What is getting changed? Only the algorithm type. So today, till today, we have understood linear regression. Probably from tomorrow, we are going to understand logistic regression. Okay, so when we do logistic regression or that upcoming classification algorithm, I'll show you how you can use the model once after saving it. So dataset is available in open source platforms like Kaggle and all. Okay, go and download from those sites, open source sites you can use for your hands-on. Yes. So friends, if you feel the session is really great, before you leave, hit on the like button and do share across your connections. Okay, ask your friends, your relatives, whomever it might be, ask them to learn these important topics, the emerging topics that are required as part of real world, right? So not providing them, probably from tomorrow we'll provide. Yes. If you have any questions, do post in the comments. We'll try to respond immediately. Thank you so much. So I'll wind up the meeting. I'll wind up the session here. We'll meet in the next session. Until then, take care. Have a great day. Signing off. Bye.